Hello, fam. We just learned box plots. We learned how to make box plots and how to determine the shape of box plots. So this last video is on comparing box plots. So I'm hoping that this video will be pretty short. I'm deliberately filming it during my lunchtime.
Mrs. McDonald, please come to the counseling center.
All day. I just heated up my lunch as motivation to make this video short but thorough. So let's get started. What we have done, like I was saying, is how do we make our box plot? Then we did side-by-side box plots, and the reason that we did side-by-side box plots is so that we can talk about comparing distributions when they are given to you as a box plot. And then we talked about what are some disadvantages to a box plot. And one of the disadvantages is that it doesn't allow you to see clusters, gaps, and peaks. So in a box plot, one of the disadvantages is you cannot see clusters, so you won't be able to see if a distribution is bimodal or multimodal. You won't see peaks and you won't see gaps. So this page was trying to address what disadvantages to box plots are. So disadvantages, you can't see modality, you can't see clusters, gaps, things like that. So let's get going on this comparing box plots. So the very top of this page is formalizing what we have already been practicing, and that is if you want to determine the shape of a box plot, measure the distance from the median to the min versus the median to the max. Now, sometimes you're just going to be able to eyeball it. So down here for Massachusetts, I can just eyeball the box plot for Massachusetts and feel confident that that guy is right skewed. And I feel the same for Maine. For me, looking at those two box plots, it looks like the right-hand side, so I'm just looking at the median to the right, looks longer than this left-hand side. So I don't actually have to go through and calculate the distance. You can if you really want to, but I'm not going to. I feel very confident that these are right skewed. And this guy, I mean, his right box is a little bit bigger than the left box, but I think that he's roughly symmetric. It doesn't have to be cut perfectly in half in order to be roughly symmetric. So if we want to actually go through and calculate the distance, we can, just like we did on the Barry Bonds info, just like we did on the Magna St. George info. You can calculate the distance, but on this guy, because I have 3 different box plots, I don't really want to have to go through and make 6 calculations. I feel pretty confident just eyeballing it and saying the shape. So the following box plots show the total income of 40 randomly chosen households from Connecticut, Maine, and Massachusetts. Compare the distribution of annual incomes in the 3 states. So we're going to compare these distributions. Now remember, when we do comparisons, we're always going to address shape, center, spread, outliers. And one thing to note is that if they give you a box plot in almost all cases, so in most cases, they want you to find IQR. So when comparing distributions, if they give you a box plot, when you do spread, they want you to look at IQR. I doubt that you're going to get 3 or 2 symmetric box plots and you're going to be able to just use range. So because it's a box plot, because it's broken up into quartiles, a lot of the time they want you to use IQR. So back to business. Maine and Massachusetts are both right skewed. But Connecticut is roughly symmetric. And what I really should have put here is that the distribution of annual incomes for Maine and Massachusetts are both right skewed, but Connecticut is roughly symmetric. So I'm going to be really careful to start all of my comparisons with the distribution of specifically what it is, and normally that'll be on the x-axis. So I could have said the distribution of annual household income. I just said annual income, so now I'm going to change it because you know how I get. That eraser is horrible, family. Okay, so I'm taking that directly from the x-axis. Okay, now we gotta find the centers for Maine, Connecticut, and Massachusetts. So what you're going to do as best you can is you are going to draw a straight line from the center down to the x-axis. So I just have a random C card here. I'm going to use that to estimate where my centers are. So I'm going to the center of the box and I'm drawing down to the axis. You can just freehand it as well. Okay, so for me, it's looking like the center for Maine is about 40,000. The center for Massachusetts, I'm just going to round up to 100. I think that that's pretty close to 100. If you want to say 90, that's fine. I'm thinking, okay, sorry about that. I had a few kids knock on my door, so I'm definitely not going to be able to finish this in this session, but I am going to finish centers with you and then probably finish recording this after school. So, I am estimating that the center for Maine is 40 or 40,000. I am estimating that the center for Massachusetts is 100. It's probably closer to 90 or 95 because you can see on my line, like my line is going to the right, but it's very, very close to 100. So maybe I'll change mine to 95. I think if you said anything from 90 to 95, you'd be good. That's a little bit better, but still not great. And then I think that the center for Connecticut is probably 60. So remember, these centers tell you what a typical observation is. So in Maine, people typically make $40,000. In Massachusetts, people typically make around $95,000. And in Connecticut, people typically make about $60,000. Now, these two are really close to each other, and this one is farther away. So that's what I'm going to say down here in my response. I'm going to say I'm noticing that Maine and Connecticut, they're pretty close for their centers, but Massachusetts is definitely larger. You could say typically residents make the least in Maine. They have a center of 40,000. Then Connecticut, they have a center of 60,000. And the residents that live in, or the people that live in Massachusetts typically make the most because their center is 95,000. So this is definitely not a one size fits all. There's not one formula. You describe it how it makes sense to me. So when I first saw it, the description that I saw first was that Maine and Connecticut are pretty close, but Massachusetts is much larger. It's a lot bigger. I think if I hadn't typed this out, I might consider saying typically people make the least in Maine. Their center is $40,000, and they make the most in Massachusetts. Their center is $95,000. And you could say Connecticut is in the middle at $60,000. So you can just order them from least to greatest if you would prefer. So now I'm going to make myself little, and I'm going to write that in. So the centers for Maine and Connecticut are only separated by about $20,000. Because remember, I got 40 and 60. And now I'm going to write Maine first. So Maine was 40,000. Connecticut was 60,000. But the center for Massachusetts is larger at 95,000. And notice I am using comparative language. I'm using the word larger. So the first thing that I do is I look at shape. The second thing that I do is identify center. And now that I've done that, I'm probably going to need to erase those so that I can draw even more lines. So when I come back, which is just going to seem like 5 seconds to you guys, but it's really going to be quite a bit of time, I'm going to do two things. I'm going to grab like a Post-it note or an index card or something, and I'm going to rewrite my response for center, because I think that having both to refer to is valuable. If you like them, then you can write down the extra one, and if not, you'll just see it written out and move on. But I would like you guys also to pause the video right now, because what we have left to do on the household income is find the spread and talk about outliers. So I mentioned that when you do spread, when comparing box plots, they usually want IQR. So what I want you to do is pause, and I want you to find the quartiles for each box. So that means that I'm going to draw a line down as best I can from Maine. I'm going to eyeball and see what do I think their quartile 1 is. And for me, their quartile 1 looks like, I don't know, 30,000. And their quartile 3 looks like 70,000 or 75,000. So you go through and match up the quartiles to what you think that they equal at the bottom. Our estimates will probably be different, and that's okay. You just do the best that you can to line them up for all 3 boxes, find the quartiles. Then unpause, come back, we'll finish the rest of this comparing, and I will give you that other way that I might have done median or center. Okay, pause, Famil. Okay, Famil, so for you, hopefully it hasn't been too long. For me, it has been 3 hours since I last left you. So I am hoping that I am where I should be in terms of what I told you. So I'm pretty sure that what I left you with is that I wanted you to go through and find the quartiles for each distribution. So you can see on mine that I had to write quite a bit, and it doesn't look pretty, but I was able to get some estimates. Now, before I get into that, I told you that I was going to write my response for comparing the centers in a different way. So if you would like this, I would highly recommend that you pause the video and copy this down. I think that this is probably more appropriate for what the AP board wants than what I have written here. So what I changed it to is households in Maine typically have the lowest annual income with a center of about $40,000. Households in Massachusetts typically make the most with a center of $95,000, and households in Connecticut are in between with a center of $60,000. So I'm adding context and I am comparing. I'm saying Maine typically has the lowest, Massachusetts typically has the highest. I doubt you needed to add Connecticut's in the middle because then that's obvious, but I just wanted to be as thorough as possible. So I would recommend that you copy this down and add it, but if you don't, my heavens, if you don't, you're probably fine. Okay, so let me go through and tell you what I estimated the quartiles to be. For Maine, I have quartile 1 being 30 and quartile 3 being 80. I just followed as best I could my line down to the x-axis. So over here, I have written that the IQR is 50. For Massachusetts, I have that quartile 1 is 40, quartile 3 is 175, so that is an IQR of 135. And then lastly, for Connecticut, I estimated quartile 1 to be 40, quartile 3 to be 90, and I got an IQR of 50. So now I'm going to use those to describe spread. And without those values, I can see that Massachusetts, its distribution varies more than the others. These two, Maine and Connecticut, they vary about the same, but Massachusetts varies more than both of them. So typically, you could just say that, especially if time was tight, you could just say, the data for Massachusetts varies the most, and the data for Maine and Connecticut varies the same and is less than the spread for Massachusetts. But because we already went through and calculated these IQRs, we're going to use them. So the annual income varies the most in Massachusetts with an IQR of about 135,000. Maine and Connecticut annual incomes vary about the same amount with IQRs of, I got 50,000 for both. So when I did this before, I must have, oh, actually, yeah. So in this blank, I would write Maine and Connecticut annual incomes vary about the same amount with IQRs. Yeah, sorry. I would just say of about 50,000. And forget this end part. I say about the same amount even though I got 50,000 on both because I'm estimating, so it could be slightly different. And then lastly, outliers, we don't have to wonder, we know for sure. So Maine and Massachusetts both have one outlier and Connecticut doesn't have any. So Maine and Massachusetts have outliers, whereas Connecticut does not. So we've talked about this before together, but comparing distributions can be very tedious, and if I'm being honest, it's one of my least favorite things in statistics. I can do it, I understand how to do it, but by the time you're done, you have to add so much context and write so many things that when you're practicing it, it gets cumbersome. Like if I have to do it on one test, then I'm fine, but when I'm practicing and I have to do it on 10 different problems, that it's so much. But we talk about this a lot. In the end, it will pay out. In the end, when you're on your AP exam and you can easily answer these questions and you don't have to worry about time, you will be rewarded for all the time that you have put in now practicing these. So I know that it's a little bit cumbersome, but I think that it's worth it in the end. So this is the first one. This is the first set of box plots that we've really gone through and compared following the SOX model. And I tried to break it out like that. So if you are paying attention, this first one is S, then this one is C, this one is S, and this one is O. So it's not exactly in the order of SOX, but it does include all of the elements. So before we finish this up, because really this is the only one that we have looked at that's comparing 2 or 3 different box plots, I want to add a couple of things, and then you guys can move on and do your can you do. So if you need a little bit of a break, take your break now and come back, but if not, we only have a little bit more and we'll just finish that up really quick. On your box plots page, before I forget, so I want you to find your box plots, the first page, because now we have 2 pages. We have this page and we have this page. I want to make sure that before we end this lesson, I am really clear about the pros and cons of box plots. So at the top of my paper on the left-hand side, I have cons. On the right-hand side, I have pros. Now, the pros are, at least for me, you can easily see 5-number summary. You can see outliers. You can see shape. So the pros for me is that they are a very good visual representation of the statistics we care about the most, which is that 5-number summary and the mean. So min, quartiles, median, max, mean, and standard deviation you're learning next. So those are the pros. You can see those summary statistics that are really important. The cons are you can't see clusters, gaps, modes, etc. It doesn't show you if it's bimodal, if there's 3 peaks, if there's a huge gap in the middle. A box plot doesn't show you any of those things. The other thing is it's like a histogram and doesn't give you information about all of the data. So on a histogram, you can at least calculate how many observations are in a data set, but on a box plot, you cannot. On a box plot, you have the advantage of seeing all of these summary statistics, but unless you're told, you don't know how many observations are in a box plot. You don't know the values in between the quartiles. So unless you are given the actual data set, it is similar to a histogram in that you don't know how many observations there are and you don't know specific values between the ones that they give you. So hopefully that is helpful. On a histogram, you can count up how many observations there are, but on a box plot, unless they tell you, we don't know n. So don't know n, which is numbers of observations, and we don't know the values between the quartiles. So Cons, can't see clusters, gaps, modes. We don't know N, and we don't know the other values besides the 5-number summary unless they give it to us. So hopefully that summarizes Boxplots up for you pretty well. It's a visual representation of the 5-number summary. It breaks your data out into sections of 25%. If we are not given the entire data set, then there are things that we cannot figure out. And lastly, one of the best things about them is that it shows you clearly the outliers. So now that we've gone through that, we only have 2 more things to do. We have this problem here, this check for understanding, and then I want you to compare the distributions of the temperatures in Magna and St. George.
Your administrators are. Head on up to the tennis court. They are playing the girls tennis team. And all 5 of our admin are up there. So get on up there and
so much.
Maybe have a good time.
So much. So I made myself big so that I could tell you that your quiz 6, it is going to be a compare the distributions problem. It's going to be 2 problems. One of them is a multiple choice that is similar to this one that you can see behind me. And then the other one is going to be a compare the distributions. And to reward you for watching this video, I'm going to tell you, you do not have to make the box plots. I am going to give you the box plots, and all you have to do is compare them. So you're going to have one question that is this that we're about to do. The box plots will be given to you, and one question that is like this multiple choice that you can see in the background. So we'll do those quickly, then you can stop this video and move on to your Can You Do. So we have the weights of male and female students summarized in the box plots. Which of the following is not correct? Okay, which of the following is not correct? About 50% of the male students have weight between 150 and 185. So we're going to go to the box plot and we're going to mark 150. So we're at the males. We want to mark 150 and 185. 170, 180, so this would be. So that is about 50%. How do I know? Because this is 25% of my data and this is 25% of my data. So the middle 50% of males have a weight between 150 and 185. So this one is true. About 25% of the female students have weight above 130 pounds. So we're going to go to 130 pounds. And that one, I believe, that was not very straight, but that's a little better. This, from 130 on, so I can erase this hopefully, and it won't mess you up. So about 25% of female students have a weight above 130. So here is my third quartile. It's about at 130. There is only 25% of the data above that. There's only 25% of the data above that. So B is true. The median weight of male students is about 162. So we go to the center. We drag this down. I think that that's probably true. The mean weight of female students is about 120 pounds. The mean weight. Well, the median is 120. And I believe that this distribution is roughly symmetric, which means that the mean and the median will be approximately the same. So if the median is 120 pounds, then the mean is probably also 120 pounds. So I'm really hoping that E is the one that is not true, because at this point that's our only option. The male students have less variability than the female students. False. The males' weights range from like 85 to 225. And the females range from, that is not 85, teacher, 95. The females range from about 85 to 143. I'll just say 145 to keep things simple. So the range for the females, is 145 minus 85, which is 60. But the range for the males is 225 minus 85, which is, I don't know. I wish I could do these in my head, but I can't. 225 minus 85, 140. So the range is more than twice as big for the males. So D is the one that is false. It says which one of these is not correct? E. The variability, the data varies, the range is bigger for the males than it is for the females. So this looks like an easier problem because it's multiple choice, but once you work it through, it's actually one of the harder ones because there's so many things that you have to go through and calculate. Hopefully, knowing that your quiz will include a question like this will better prepare you so that you know you're really going to have to analyze the data in a box plot in order to answer questions on this quiz. One thing that I want to add in, and I'm sorry to do this because I know this video is already very long, but if they would have told you that there are 200 male students, they may ask you something like, how many weigh more than 162 pounds? If I didn't tell you that there were 200 students, you couldn't calculate this. We have no idea how many male students we looked at and how many female students we looked at. We could have looked at 200 of each, 200 male and 200 female, but without being told, we have no idea how many males were looked at and how many females were looked at. But if I tell you there were 200, how many weigh more than 162 pounds? Remember, you can calculate this by coming to 162 pounds, realizing that's the median. So 50% of the boys weigh more than 162 pounds. So you would do 50 times 200, and that would tell you 100 boys weighed more than 162 pounds. So you will get questions like this on your review and on your test. So you need to remember that if you know a percent and they give you a number, you can multiply them together to figure out how many is 50%. Okay, last one is also practice for the quiz, and it is to compare these distributions. So when you compare them, make sure that you use comparative words. And because they give you these summary statistics, you actually use values because they will be easy to find. So you should pause this, write out your answer, and then just come back and check, because this is exactly what you're going to do on your quiz. I'm going to give you 2 box plots. I think it's 3 actually. I'm going to give you 3 box plots, so it's going to be more like this. It's going to be one of these. And you need to compare them like this. So you practice here. Pause the video, and when you unpause, I'll be showing you what I wrote down. Okay, this is not the only way that you can write it. So you can just use it as reference if you've hit all of the elements, shape, center, spread. Okay, sorry, I ran out of space. What I was saying was if you hit all of the elements, you don't need to go through and change your entire response. Just use mine as a framework for what you need to mention. So the distribution of temperature for both Magna and St. George are roughly symmetric. Magna has an outlier on the lower end, 45 degrees, and St. George has an outlier on the upper end, 88 degrees, which makes sense because we all know St. George is very warm, and out here in the valley it tends to get a little bit colder. Notice that I'm not saying roughly symmetric and unimodal, because I don't know if it's unimodal. All I know is that it's symmetric. These could be bimodal for all I know. So distributions are both roughly symmetric, and each one of them has an outlier. St. George is typically warmer than Magna. The median temperatures are 74 degrees and 66 degrees respectively. That's not the only way you can say that, but you definitely want to mention something like St. George is typically warmer than Magna. The temperatures in Magna vary more than the temperatures in St. George. Excluding the known outliers, the range for Magna is 28 and the range for St. George is 23. So I'm noting that the temperatures vary more in Magna, and then I'm giving the range for those cities. And then I say if the outliers are included, then the range is 34 and 26 respectively. So I've hit all of the elements: SOX, shape, outlier, center, spread. Shape, roughly symmetric. Outliers, 1 for Magna, 1 for St. George. Center, it's typically warmer in it's typically warmer in St. George because the median is 74, and in Magna it's only 66. The temperatures in Magna vary more than in St. George, and you can tell that by the length of the box plot. The length of the box plot tells you if it varies more. If you have a really long box plot, like on this multiple choice problem, like you can totally tell that males vary way more than females, because this one's almost twice as long. The male distribution is almost twice as long as the female. So that had me at spread. So shape, outliers, center, spread. Okay, if you have any questions between now and your quiz on whatever day you take it, please email me if you're not going to see me in class. And even if you are going to see me in class, you might want to email me. You still have a can you do that you need to get done. So if you're crunched for time, at least you now know that what is going to be on your quiz is a question like this, a question like multiple choice, and a question like this, compare the distributions. You do have a couple of practice problems for this in the can you do, and you have, I think, one problem like this for practice in the can you do. Now, one last thing. It might be worth it for you to hang in just 1 second. On this problem for river X, Y, and Z, these concentrations are decimals. So like if you want to know the median for river Z, I estimate that that's like 4.3. My recommendation to you on this problem is to find the medians only, estimate the medians only, and then from there just compare what you can see. So what I mean by that is you'll want to say that in river X, the concentration is higher than in the other rivers, and you want to give the typical concentration level. But then after that, don't worry about finding the range or the IQR. Just compare them. And what I mean by that is river X, the data varies more than for river Y and river Z. So as long as you're making comparative statements for this one, don't go through and estimate all the values because that's just way too unrealistic and way too much work. So find the medians and then from there, just make comparative statements. Okay, that's it. This is a longer one. I really am, but what do? We need to know all the things. So I guess I will just be in a permanent state of teacher guilt. But I love you guys. So I'm in it with you. I am spending the time too, so at least we're in it together. Okay, I'll let you go. Love you guys.